All right, let's look at a couple of practice problems in resolving vectors. Let's start with this one, number 6. This is actually on the vectors homework on the back. This guy, Freddie Freeloader, he hikes 14,700 meters on a heading of 35 degrees southeast. What are the south and east components of his displacement? I'm going to draw the vector first. 14,700 meters. And it's 35 degrees to the southeast. All right, and my x component will be here. My y will be here. In this case, y needs to be your opposite, x needs to be your adjacent in order for everything we've talked about to be true. So, to find the x component, remember that x is v. Well, we'll call this delta d because this is a displacement. Delta d times the cosine of the angle. That's all we have to do. Delta d is 14,700. Cosine and the angle is 35. Punch that directly into your calculator. 14,700 cosine 35. 14,700 cosine 35. Hit enter. 12,041.5. I'll just put 12,041. 12,041 meters in the direction east. To find the y component, remember the y is whatever the hypotenuse is, in this case delta d, displacement of sine theta. Delta d is 14,700. That's our hypotenuse of the triangle. Sine of 35. So 14,700 sine 35 gives us 8,432. Meters is the units. Direction is south. To the south. That's our x and y component. This actually probably should have been 42 because it should have rounded up. We took everything into account with this. My x component goes to the right because the velocity vector is clearly going to the right, not to the left. Y went down because this one is clearly going down, not up, and it ended up with head at a tail, so everything is good here. Those are my two components. What about 7? Now we have a velocity. Just because it's a velocity or a distance or a force, it doesn't change how we do it. It just changes what they actually give us. So we have a cannonball now, and it's launched at 97 meters per second at an angle of 40 degrees above the horizontal. So here's my horizontal. Find the x and y components. This will be the first step of these type of problems. You'll have a lot of problems that will start out this way, and this is always the first step. There's the x component. There's the y component. X going to the right, y going up. Head meets tail. We're good to go. X component is v cosine theta. V because now we have a velocity. V cosine theta, that is 97 cosine 40. And let's just go ahead and write down the y. The y component is v sine theta, which gives us 97 sine 40, and I can punch that into my calculator real quick. 97 cosine 40, that's my x component, gives me 74.3. Meters per second is still the units, and the direction for my x component is, well, let's just call this right. You can call it east if you want as well. Right or east, some positive direction. Doesn't really tell us actually what direction. We could have very well drawn the picture going this way and it would have been right because this doesn't say exactly what direction we're going. But we'll just give it a direction. Y component, 97 sine 40 gives us 62.4. And that one is going up, definitely up. So these two vectors combine to create this one. This is the y component, that's the x component.